Hello, everyone. Today we're going to walk through Business Logic Domain Service in the Devum platform. We already have our Devum HR tutorial application, and using this application, we'll take up a real-world use case. Through this use case, we'll understand how to configure and write logic using a Devum Business Logic Domain Service. The use case we've chosen is to calculate the total leave count and the pending leave balance for an employee, broken down by each leave type. So let's get started. First, we'll navigate to Domain Services. From here, we'll click on Add New and then select Business Logic. Now, we'll provide a name for the service. Let's call it Employee Leave Count. We can also provide a brief description to explain its purpose, although this step is completely optional here. Next, we'll choose a group, which is also optional. Once that's done, we'll click on Continue to proceed. Now we're inside the workspace, where we'll start writing the logic for our business service. To begin, we'll click on the plus button. This is how we create input parameters for our use case. For this logic, we need two inputs. One is the employee ID, and the other is a list of leave types. First, we'll create an input named Employee ID. We will select the data type as string and mark it as optional. Next, we'll create another input called Leave Type. For this input, the data type will be data table, and we'll also mark this as optional. So what exactly is a data table? A data table is basically an array of structured data, which means it can store multiple records. In our case, the leave type data table will contain multiple leave types, such as casual leave, sick leave, LOP, and so on. Since we're working with multiple records, we're using a data table here. So these are the two inputs required for our use case. We'll now click on Continue, and the inputs are created. At this point, the leave type input is still shown as a generic data table. To make it meaningful, we need to bind an actual schema to this input. When I click here, I get an option to select a schema name. All our leave types are already stored in a schema, so we'll select the leave type schema from the list. Using this schema, we'll proceed. Now we can see all the available fields. We'll click on Continue. As you can see, the input is now properly bound to the leave type schema. Now that all the input values are in place, we can move ahead and focus on the output of this business logic. What we need to return here is the total leave allocated count and the total pending leave count for an employee. And these values should be calculated and returned separately for each leave type. Since we're returning data for multiple leave types, the output will also be a data table. By default, the return type is set to string, but we can change it based on our requirement. We'll change the return type to data table, enable array or multiple values, and mark it as optional. Then we'll click on Continue. Now it's asking for a schema. Since this is a custom response, we'll define an anonymous schema. We'll click on Define Anonymous Schema and name it Leave Count Response. Now let's define the fields we want in the response. Leave type ID to string, leave type name to string, leave pending count to double, and leave allocated count to double. We're using double here because leave values can be decimal, for example, half-day leaves, or values like 2.5 can be calculated. Now, as we define the output fields in the video, let's quickly understand why we're structuring the response this way. Here, our requirement is not just to calculate leave counts, but to return the data in a format that is easy to consume by UI, workflows, or even other domain services. That's why we're using a data table as the response, because we're dealing with multiple leave types for a single employee. Each leave type can have a different allocation and a different pending balance. So representing this data as a list makes the logic more flexible and scalable. Additionally, I'm also including employee ID in the response, which will be useful for future logic or integrations. We'll keep it as string. Once all the fields are configured, we'll click on Continue. Now we can see the response schema created successfully. Before building the logic, let's review the schemas. We use leave type, leave apply, and employee leave type to calculate each employee's total and pending leave count. To retrieve the list of leaves applied by an employee, we use the DB filter function. This function queries the selected schema with the required filter conditions. After dragging and dropping the DB filter function into the workspace, it will be added to the flow area. From the drop-down, select the HR Leave Apply schema. All employee leave requests are stored in the HR Leave Apply schema. By applying a filter on the employee name with the operator set to equals and passing the employee ID from the input. The leave type field is shown with square brackets, which indicates that it is a data table data type. In the DB filter function, when we filter the HR Leave Apply schema using the employee name, the result returned is a data table. That's why near variable _1, the schema name is displayed with square brackets, indicating that variable _1 holds a data table type value, not a single record. Here, we rename the variable one as employee leave filter. There are two ways to add functions, either by dragging and dropping from the function panel or by directly typing the function name in the workspace. Search for the required function in the workspace and select it. Once selected, the function is added to the flow. Next, we apply another filter on the employee leave type schema. This schema maintains the leave allocation details for every employee, mapped against each leave type. Using the drop-down list, select the employee leave type schema so that we can filter and fetch the allocated leave information for the selected employee and leave category. Here, we filter records where the employee equals the given employee ID. This gives us the leave allocation details for that employee. Similarly, each leave type and its allocated count are available in this schema. So now we have the allocated leave data for the specific employee. To calculate the pending leave count, we need to perform some logical operations. We'll move on to those logical calculations in the next step. To save time, we have completed the entire business logic. Now, let's walk through what we have implemented step by step. Next, as mentioned earlier, the map function is used in the flow. Map acts as an iterator. When a leave type data table is given as input, it iterates based on the number of records available in that table and processes each record one by one. We have named the iterator variable as each, but users can rename it to anything they prefer. Next, the find first function is used. This function takes a data table as input and returns a single record based on the applied filter conditions. In the find first function, variable _2 is passed as the input because it contains all leave allocation records for the employee across different leave types. To calculate values for each leave type, we apply a filter where the leave type ID matches each .id. This returns the allocated leave record for the specific leave type. Next, we work with the leave apply data. We already filtered the leave apply schema for the selected employee earlier, so this variable contains all leaves applied by that employee. From this data, we further filter by leave type to get only the records for the current leave type. This gives us a list of leave applications for that specific leave type. Using this filtered data, we calculate the total number of days the employee has applied for that leave type. We use the sum function to calculate the total applied leave days for each leave type. In the leave apply schema, the number of days field is already computed when each leave request is saved. By summing the number of days values from the filtered data table, we obtain the total leave days applied by the employee for that specific leave type. In the sum function, a data table is provided as input, and the required field, of type long or double, is selected. The function performs the sum operation on that field and stores the result in a variable _6 with a double data type. In the employee leave type schema, the allocated leave count is stored as a long data type. We use the convert to double function on variable _4.leave_count. Since variable _4 contains the complete leave allocation record for the employee by leave type, we select the leave _count field from it and convert that value into a double for processing. The subtract function is applied to determine the remaining leave balance for the employee. Here, variable _7 represents the total leave allocation for a specific leave type, and variable _6 represents the total leave consumption for that leave type. When we subtract variable _6 from variable _7, the function returns the pending leave count, which indicates the number of leaves still available for the employee under that leave category. Now that all required values are calculated, we construct the response using the basic service response builder. Here, we select the output fields that were defined while creating the basic service. The employee ID field is mapped directly from the input parameter. By returning the employee ID in the response, it can be reused as an input for other logic or processes in the flow. The leave allocated count field is mapped from variable _7, which holds the allocated leave value fetched from the employee leave type schema. The pending leave count is mapped from variable 8, which is calculated as allocated minus applied leaves. In the response, we send the leave type ID and name along with the allocated and pending leave counts, so the system can show a full leave summary for the employee. The response is returned from the map using the return type function. For each leave type, the logic runs and the results are collected into variable _3, which is finally returned as the business logic output. This completes the business logic implementation. Once everything is verified, we publish the changes. After publishing, the business logic is ready to use. This completes the use case where we calculate allocated leaves, applied leaves, and pending leaves for a specific employee in the HR system. Thank you.